We are continuing on with this activity, and we are starting on domain, range, and function of a continuous graph. So we've already learned domain, we've already learned range, we've learned what a function is. Now we're going to talk about it in regards to a continuous graph. So this is what we're talking about. Actually, let's go take a little step back first, shall we? So hopefully everybody remembers how to graph an inequality. An inequality is considered to be one dimension because you just have one line. The reason why graphs are considered to be in two dimensions is because you have an x-axis and a y-axis, so you have two different dimensions to graph upon. But when we did our inequalities, we just had x, one variable, so it was one-dimensional graph. So hopefully you guys remember that when we were graphing these things, that we had to pick 3 points. So the number we were talking about, which is 3, a number less than it, 2, a number greater than it, 4, and I always circle the number I'm talking about. And then I check, is it included? There's a line there, so it's included, so it gets filled in. And then I always circle my variable, and I ask myself, is there a mouse or a gator facing towards the variable? In this case, there's a gator facing towards it, and the gator is greater, so we're going to the right. You gotta sound like a chicken when you're doing it, or a turkey. And then we talked about how we take our arrow, we start from left to right, and we say, okay, the first number I see is 3. And I see this arrow going off into infinity. And then I say, is the 3 included? And we say, yes, the 3 is included, but the infinity is never included. So this is interval notation. This shows every single possible point between 3 and infinity. We're going to be using this to talk about continuous graphs. So let me show you what I mean. So we know the domain of the function is the left and right extremes of the graph. So from left to right. Now I can't write all the points possible on this line, but what I can do is do something called interval notation, which we've already learned. And so when we're talking about interval notation, we say, when we're looking at the domain is the x value, and the x value is this line. And even though my red line goes from here, see if I can do this again like this, goes from here all the way up to here, I can sort of measure it on that first dimension, that x-axis. So I say, okay, well, where does it start as I read from left to right? And I see it starts at -3. And then I go along and I say, okay, where does it end? Maybe I should do my arrow, because we've done that before. So it started at -3, and where does it end? It looks like it ends at 8, right? And then a comma between them, and I say, okay, well, this is included. Well, it's a filled-in circle, so a filled-in circle means included. And that's a filled-in circle, so again, that gets a bracket. So the domain of this particular function is -3, 8. Now, let's look at the domain of this function. We're going to do the range afterwards. The range of this function, again, we're talking about the x-axis, and we're going to measure it. Now, what happens here is I have a start. It starts at -3, right? So we're looking at this red line again, people. The red line that goes from here, and then there's this arrow here. And so it starts here, the red line on the x-axis, that's at -3. So I'm going to put the domain starts at -3, comma, and then the thing is that this is an arrow. What does that arrow mean? Well, just like we did with one dimension, if I was to follow that red line that's going down this way on the x-axis, it just means that the x-axis goes on forever and ever and ever in this direction. So we represent that just like we did with inequalities. We represent that with the infinity sign. And then we go back and we say, okay, well, this circle's filled in, so this is included. But because this arrow goes on and on forever, we call that infinity, and that's never included. So some people will say, well, how come you didn't put the set notation? I don't put set notation because I don't have individual points. We can use interval notation to show all the points that are included there. So basically -3 and any number above it. Okay, so the second part of this says to check for the range. And we know that the range isn't the left and right, the range is the down and up. And notice I said down and up because we read from the bottom to the top, from the least to the greatest. So if I click and get rid of these ones, I'm no longer talking about left and right, I'm talking about up and down. So I go and click, and up and down for this one is, or down and up, excuse me, is from this one up here. And again, people say, I don't understand what you mean. Well, imagine yourself with a line here, and you say, okay, as I go up on this red line, where do I first see the red line? And it's right here. And where does that coincide with the y-axis? It coincides with the y-axis at 2. So I would write a 2. By the way, we're talking about range. So I'm going to put that here. And then if I keep going up on this, where does it end? Well, it looks like that red line, if my line was straight, ends at 7. So I put a 7. Then I always go back and ask myself, just like I did with inequalities, is this included? Well, it's a filled-in circle, so it's included. If it was an open circle, I would say parentheses. And then when I go back up, that one's a filled-in circle as well, so that gets a bracket as well. So this is from, the range is from 2 to 7. The domain is from -3 to 8. That's the first one. Now on the second one, again, we're no longer talking about from left to right. When we're talking about the range, we're talking about from bottom to the top. But when we're talking about that, we need to talk about something called end behaviors. End behaviors means when it doesn't stop on the graph, it keeps going. We have to say, well, where does it end? Well, because of this arrow right here, that's just going to, if this kept on going, this is just going to keep on going forever and ever. Its end behavior ends in the infinities, just like we said up here. So again, though, we go from the bottom to the top. So if I draw a line, say, where's it start? Well, it never actually starts because it goes on forever. So we just have to know, because of that end behavior, we know that it starts at infinity. But the infinity isn't positive because I'm going down, and down is negative. Up is positive, so this would be negative infinity, comma. And then where does it end? It ends right here. But that coincides to a 1 on the y-axis. So it ends, or -1, excuse me. And then I go back and say, is infinity ever included? And the answer is no. But is it included on here? Well, this is a filled-in circle, so this becomes a bracket. So my range is from -infinity to -1. And in this way, I've listed the entire domain in the range. So we're going to do a couple more of these, but this time, I want you to do that whole pause thing, try it, and then see if you're getting it, because you're not a passive watcher. You are actively trying to learn this. So here we go. Boom. Some people say, well, what is this? Well, this is continuous, isn't it? It's continuous from the domain of 1 to the domain of 3, and from the range of 2 to the range of 4. So I would argue that this is a continuous function. Is it linear? Well, that looks like a straight line to me, so I'll say, yes, it is linear. Is it a function? Well, does it pass the vertical line test? Let's check. Yes, it doesn't touch the line more than once, so this is a function. Now, we got to do the domain and range. Well, Mr. Nelson came up with this great idea. We call this the running man. And we say, okay, if the running man was running on the x-axis, where would he first encounter the line? Remember that the domain is the x values. So we put a D here. And we say, well, he would first encounter that line right here when x is 1, right? And then he keeps walking along. He's looking up the whole time. La, 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 life is good. Oh, wait a second. I see that it ends here at x is, I went a little too far, x is 3. So I go to 3, comma between them, and then I go back and say, is this included? Well, it's a filled-in circle, so it gets included. And this is a filled-in circle, so it's included. So people say, well, why don't you say 4? Well, because 4 is up and down. The x values are what I'm looking at when I'm looking at the domain. So then the next thing is to find the range, and the range values are up and down. So we're going to go the other way. I think we call x Xavier and y, what do we call y? Yolanda. Yolanda is my y. She's doing her little dance. And she's like, so if she's going up, she's not going this way, she's going up and down, she's doing her little dance. Oh, I see at 2 that my y starts. And then I say, okay, I keep going up, and Yolanda goes, oh, snap. She says, oh, the line stops at 4. So I put a 4 there. This is a filled-in circle, so it gets a bracket. And this is a filled-in circle, so it gets a bracket. So there's my domain, there's my range, and I've answered all these questions. So on the next slide, pause it, see if you can do it, and then I'm going to go over it. Here we go. Pause, try to answer it, and now I'm just going to go through it. These should go pretty fast. Is this linear? Yeah, I'd say that's linear. Yes. Discrete or continuous? Well, it's discrete if you're looking at the whole graph, but it's continuous from here to here. There's no breaks in it, so I'm going to say continuous. Is it a function? It passes the vertical line test. So yes, it is a function. That's pretty cool. Now, can you find the domain and the range? Well, if I'm doing the domain, that's the x-axis. That means I'm starting with Xavier, and he's walking in the line here. He's like, dum, 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 dum. And he goes, oh, right here, I see, if I look down there, I see that's where my x starts. It starts at -6. Cool. And then I keep on walking. Hey! And I look up and I see that my line stops at 4. Right? And now I go back and say, is this included? Well, it's filled in, so this is included. But this is an open circle, so which means it's not included. It gets a parenthesis. So that is the domain from here to here. Now, to find the range, that's y value. So we're talking to Yolanda. And Yolanda says, okay, I always come from the bottom top. She comes up the y-axis. Hey! She spots right there that the y-axis starts at -1, 2, 3, 4. So it starts at -4. All right, so, and where does Yolanda stop? 1, 2, oh, she says at 3, I see that it stops. So I go back and say here, when I was going up and down, I see that this was included. And up here it was not included, so it's parentheses. So there's the domain and the range of my function. Hopefully this is getting a little bit easier for you. So again, and I want you to go ahead and try to answer all these questions really quick. You should be able to. Okay, I'm assuming you did pause. So here we go. First thing's pretty simple. Is it a line? Is it linear? Yes. Is it discrete or continuous? It is continuous from this point to this point, so we'd say continuous. There's no breaks in it. Is it a function? It passes the vertical line test, so yes, it is a function. And finally, we get to the domain, and this is where we use the help of Xavier. We call him Xavier because he's an X, and we've used the range. We use Yolanda because she's Y. So Xavier, we say, hey, Xavier, get over here. I want you to start walking across here, and Xavier starts walking across here. And as he's walking across, he says, oh, at 2, he looks up, and he says, oh, I see the X's are starting. So he puts a 2 here. Then he keeps walking. Oh, look at that up there. At 6, he's got another number. So then we go back, and they're both circles are filled in. So this is included and this is included. And so there's the domain. It's all the values from 2 to 6. Now that Xavier's done, we'll ask Yolanda to help us. Yolanda goes up and says, okay, I start, and as I'm moving up, oh, at 20, I see that I start seeing my y values. And then I keep going up, and I see at 40, they stop. And again, I look at this and I say, filled in, so it's included, and 40 is included, so my domain and the range for this function are as follows. Hopefully that was easy for you. Okay, pause, do it. Okay, I'm assuming you did it. Did you say this is linear? I hope so. Is this continuous or discrete? Well, these arrows tell me that it keeps on going, so I'm going to say continuous. Is it a function? Well, does it pass the vertical line test? The answer is yes, it does. So this is linear. Yes, and let me see if I can pull this down a little bit. There we go. And now the domain and range again. So this one's a little bit different than the last one, and the reason why it's a little bit different is because of the arrows I have at the end of the lines. When we look at arrows, we talk about something called end behaviors. And what that means is, while I don't see the end of it, where does it eventually end? And just like we did with when we did one dimensions and inequalities, if we're looking at Xavier, and he's going from left to right, he sees that it goes forever that way. We'd never actually be able to start because it goes forever to the left. So the end behavior, when it goes in the negative direction, we call that negative infinity. And then Xavier walks across the x-axis and he looks up. He sees that the arrow keeps on going and on forever to the right, and that's infinity in the positive direction. And since infinity can never be included, this is the domain. That means that there's basically every single value will work. You can plug in anything for x. So then the range, well, again, we don't need, and by the way, that should have been a D for domain and a dot dot. For the range, we're looking at the y values, and we're going to look at Yolanda. And we say Yolanda, as she goes up, it doesn't look like it starts to here, but you have to remember that this arrow continues on. Its end behavior, it goes on forever. So Though you may not see it here, because that arrow suggests it, that end behavior, we know that it starts at negative infinity, and then, wow, just have one of those days. And then, as she goes up, she sees that the arrow keeps going on forever, so it goes in the positive infinity direction forever. And again, infinity is never included, and so the domain and the range are as follow. And you're going to see that with pretty much any line that you have going on forever.